A marketing funnel is a picture of the customer's journey from first awareness to a final purchase or other desired outcome. Think of a kitchen funnel. You pour a lot of liquid in at the wide top, but only a small amount comes out the narrow bottom. The same happens with prospects. Many people see an ad, fewer click, fewer fill a form, and still fewer become paying customers. Typical stages using a B2C e-commerce example. Awareness, impressions, reach, video views. Interest, clicks, page views, time on site. Consideration, add to cart, product page depth, email sign-ups. Intent, checkout, start, coupon code entry. Conversion, completed purchase, revenue. Post-purchase, repeat purchase, referrals. Core metrics for each stage are simple ratios. Impression to click rate, CTR equals clicks divided by impressions. Click to lead rate equals leads divided by clicks. Lead to sale conversion rate equals sales divided by leads. Overall funnel conversion equals sales divided by impressions. These numbers let you see where the funnel is wide, many prospects, and where it is narrow, high drop-off. The goal of funnel optimization is to widen the narrow parts without spending too much extra money. Conversion rate optimization, abbreviated CRO, is the systematic process of making small changes to a page or a step in the funnel and measuring the effect on conversion. The most common tool is a /B testing, where version A, the control, is shown to half the traffic and version B, the variant, to the other half. Steps. Identify a hypothesis. For example, changing the add to cart button color from blue to orange will increase clicks. Define the metric, click-through rate, abbreviated CTR, or conversion rate, abbreviated CR. Calculate sample size using the formula. N equals 2 times open parenthesis Z sub 1 minus alpha over 2 plus Z sub 1 minus beta close parenthesis squared times P times open parenthesis 1 minus P close parenthesis divided by delta squared, where P is the baseline conversion rate, delta the minimum detectable lift, and Z values correspond to confidence, usually 95%, and power, 80%. Run the test for enough days to reach N. Analyze results with a 2-proportion Z test or a Bayesian posterior. If the p-value is less than 0.05 or the Bayesian probability is greater than 95%, you declare a win. Statistics snapshot. In a 2022 e-commerce study of 5,000 A/B tests, the average lift was 7% with a 30% probability of a negative effect. That tells marketers to test many ideas. Most will be small, but a few can be big wins. Other CRO tactics include heat map analysis, form field reduction, social proof badges, urgency timers, and personalized product recommendations. Explanation. Attribution modeling decides how much credit each marketing touchpoint receives for a conversion. Imagine a soccer match where the goal scorer gets all the glory last touch, but the defender who passed the ball earlier also helped first touch. Different models allocate credit differently. Common rule-based models. First touch, 100% credit to the first interaction, useful for brand-building channels. Last touch, 100% to the final click, favored by performance marketers. Linear, equal credit to every touch, good for balanced view. Time decay, more credit to recent touches, less to older ones, recognizes recency. U-shaped, position-based, 40% to first, 40% to last, 20% split among middle touches. Data-driven algorithmic models use statistical methods such as Markov chains or Shapley values to estimate the incremental contribution of each channel. Example: a Markov model builds a transition matrix where each state is a channel. The probability of moving from channel A to channel B is measured from user paths. The removal effect, how overall conversion drops when a channel is removed, becomes its credit. Why it matters: accurate attribution tells you where to invest. If a display ad is always the first touch but never gets credit under last touch, you might under-budget it despite its real influence. Customer lifetime value, CLV, is the forecasted net profit you expect from a customer over the whole relationship. It turns the funnel from a short-term conversion problem into a long-term profit problem. Simple CLV formula for a subscription SaaS. CLV equals the sum from T equals 1 to T of R sub T minus C sub T, divided by 1 plus D to the T, where R sub T equals revenue in period T, for example monthly subscription fee. C sub T equals cost to serve in period T, such as support or hosting. D equals discount rate, reflecting time value of money, often 10% to 12% annually. T equals expected lifetime in periods, for example months. Practical shortcut for a stable monthly churn C and average monthly margin M. CLV approximately equals M divided by C. If monthly margin equals $15 and churn equals 5%, CLV approximately $300. Influence on funnel decisions. Acquisition cost ceiling. If CLV equals $300, you should not spend more than $150 to $200 to acquire a customer, allowing for other costs. Channel prioritization. Channels delivering low-cost, high CLV customers get more budget. Retention focus. Raising CLV by reducing churn, for example better onboarding, often yields higher return on investment than acquiring new leads. Marketing mix modeling, abbreviated MMM, is a statistical technique that quantifies how each element of the marketing mix, price, promotion, product, place, drives sales. Think of it as a chef tasting a soup and figuring out how much salt, pepper, and broth each contributes to the flavor. Sales sub T equals beta 0 plus beta 1 times TV sub T plus beta 2 times digital sub T plus beta 3 times search sub T plus beta 4 times price sub T plus beta 5 times season sub T plus epsilon sub T. Sales sub T total revenue in period T. TV sub T, digital sub T, search sub T, spend or impressions on each channel. Price sub T, average selling price. Season sub T, dummy variables for holidays and so on. Beta coefficients capture the media elasticity, sales increase per dollar spent. Integrating funnel data. Instead of using total sales, you can model funnel conversions at each stage as separate dependent variables. Add to cart sub T equals alpha 0 plus alpha 1 times paid search sub T plus alpha 2 times social sub T plus alpha 3 times email sub T plus epsilon sub T. Running several linked regressions gives a granular view of how each channel pushes prospects from awareness to intent. Why use marketing mix modeling with funnel data? Identify diminishing returns. For example, after $50,000 in Facebook spend, add to cart growth stalls. Allocate budget to the mix that maximizes the overall funnel conversion rather than just top-line sales. Simulate what-if scenarios, for example, cut TV spend by 20% and increase SEO by 30%. ROI optimization across funnel stages asks, given a total marketing budget B, how should we split it among awareness, consideration, and conversion activities to get the highest overall return? The step-by-step framework. 1. Estimate marginal ROI for each dollar spent at each stage. Marginal ROI equals delta revenue divided by delta spend. This can be derived from marketing mix modeling or from past A/B test lifts. 2. Rank stages by marginal ROI high to low. 3. Allocate budget starting with the highest ROI stage until its marginal ROI falls to the level of the next stage, diminishing returns. Mathematically, you solve a constrained optimization. Maximize over x the sum from I equals 1 to n of ROI sub I of x sub I, subject to the sum from I equals 1 to n of x sub I equals b, x sub I greater than or equal to 0, where x sub I is spent on stage I and ROI sub I of x is a concave diminishing function often modeled as ROI equals a I minus bi times xi. The Lagrange multiplier method gives a I minus 2bixi equals lambda. All stages where the marginal ROI equals the same lambda receive spend until the budget is exhausted. Practical example, an online retailer has $200,000 total budget. Past marketing mix modeling shows. Awareness social video, marginal ROI equals 4 minus 0.01 times x. Consideration search pay per click, marginal ROI equals 6 minus 0.015 times x. Conversion, retargeting, marginal ROI equals 8 minus 0.025 times x. Solving yields roughly $50,000 to awareness, $70,000 to consideration, $80,000 to conversion, maximizing overall profit. Predictive analytics uses historical data to forecast future funnel performance. The simplest tool is linear regression, which fits a straight line through data points. Basic model for predicting next month conversions, C from spend S and website traffic T. C equals alpha plus beta 1 S plus beta 2 T plus epsilon. Alpha equals intercept baseline conversions when spend and traffic are 0. Beta 1 equals effect of each dollar of spend. Beta 2 equals effect of each 1,000 visitors. Epsilon equals error term unexplained variation. Collect data monthly spend clicks impressions seasonality, dummies, past conversions for at least 12 to 24 periods. Split into training 70% and test 30% sets. Fit the model using ordinary least squares, OLS check R squared explained variance and p-values for significance. Validate compare predictions on the test, set compute mean absolute percentage error MAPE. Forecast plug-in plan spend and traffic forecasts to get expected conversions. Advanced techniques. Polynomial regression for nonlinear effects, e.g. saturation. Time series models a RIM, a profit to capture trends and seasonality. Machine learning models random forest gradient boosting, when many predictors, creatives, keywords, device type exist. Real-world analogy like a weather forecaster using temperature, humidity, and pressure to predict rain marketers. Use spend clicks and season to predict how many leads will flow through the funnel. Segment-level funnel analysis breaks the overall funnel into distinct audiences segments, such as age groups, acquisition source, or geography. Cohort retention modeling then follows a group of users who entered the funnel at the same time, a cohort, to see how many stay active over later periods. Cohort table example - monthly cohorts for an app. Cohort month Jan 2025 pipe day 0 users 5,000 pipe day 7 retention 2,550% pipe day 30 retention 1,224%. Cohort month Feb 2025, pipe day 0 users 4,800 pipe day 7 retention, 2,450%, pipe day 30 retention, 1,327%. Retention rate formula (R sub T equals U sub T divided by U sub 0, where U0 is the number of users at cohort start U sub T, the users still active at time T. Y segment. A 25 to 34 age group may have a 40% drop-off after the product page, while 55 plus may drop off earlier at the ad click stage. By identifying weak points per segment, you can tailor CRO tests, different copy UI offers. Actionable insights. 1. Calculate segment funnel conversion rates, for example, email sign-up to trial to paid for each segment. 2. Plot cohort retention curves to spot if a segment churns faster. 3. Run targeted interventions, for example push notifications, for low retention, cohorts personalized onboarding for high-value segments. Quantitative funnel leakage diagnosis measures the exact number of prospects lost between each step and tries to find the root cause. Think of a water pipe with several joints. Leakage at a joint reduces flow downstream. The math tells you how much is lost, and diagnostics tell you why. Leakage calculation for each stage I. Leak I equals count I minus 1 minus count I. Leak percent I equals leak I divided by count I minus 1 times 100. Example e-commerce. Impressions 200,000. Clicks 10,000. Leak percent click equals 200,000 minus 10,000 over 200,000 equals 95%. Add to cart 2,000. Leak percent ATC equals 10,000 minus 2,000 over 10,000 equals 80%. Purchase 500. Leak percent purchase equals 2,000 minus 500 over 2,000 equals 75%. Root cause analysis framework. Collect qualitative data, heat maps, session recordings, survey responses at the leaking step. Segment the leakage. Is it device-specific, geography-specific, or source-specific? Statistical testing. Use chi-square or logistic regression to see which variables significantly predict drop-off. Hypothesis and test. If high mobile drop-off, hypothesize button size too small, run an A/B test. Illustrative example. A SaaS landing page shows a 60% bounce after the headline. Heat map shows users scrolling past without reading the value proposition. The team adds a short video above the fold and A/B tests. Bounce drops to 40%, confirming the cause. Scenario: an online retailer has a monthly marketing budget of $300,000. Historical data, MMM, provides the following marginal ROI functions for each funnel stage: awareness, social and display: ROI underscore of X equals 5.0 minus 0.015X. Revenue per dollar spent. Consideration, search and content: ROI underscore C of X equals 7.0 minus 0.020X. Conversion, retargeting and email: ROI underscore V of X equals 9.0 minus 0.030X. All ROI values are in dollars of revenue per $1 spent. The functions are valid up to the point where ROI becomes zero. Task: allocate the $300,000 across the three stages. Variables X underscore A, X underscore C, X underscore V to maximize total expected revenue. 1. Formulate the objective: maximize R equals integral from 0 to XA of ROI underscore of U do plus integral from 0 to XC of ROI underscore C of U do plus integral from 0 to XV of ROI underscore V of U do. Because ROI is linear, the integral simplifies to a quadratic. R equals 5xa minus 0.0075x a squared plus 7xc minus 0.010xc squared plus 9xv minus 0.015xv squared. 2. Add the budget constraint: xa plus xc plus xv equals 300,000. 3. Use Lagrange multiplier. Lambda: script L equals 5xa minus 0.0075x a squared plus 7xc minus 0.010xc squared plus 9xv minus 0.015xv squared plus lambda times open parenthesis 300,000 minus x a minus xc minus xv close parenthesis. Take partial derivatives and set to 0. Partial L partial x a equals 5 minus 0.015x a minus lambda equals 0. Partial L partial xc equals 7 minus 0.020xc minus lambda equals 0. Partial L partial xv equals 9 minus 0.030xv minus lambda equals 0. 4. Solve for each x in terms of lambda. Xa equals open fraction 5 minus lambda over 0.015 close fraction. Xc equals open fraction 7 minus lambda over 0.020 close fraction. Xv equals open fraction 9 minus lambda over 0.030 close fraction. 5. Insert into budget constraint and solve for lambda. Open fraction 5 minus lambda over 0.015 plus open fraction 7 minus lambda over 0.020 plus open fraction 9 minus lambda over 0.030 equals 300,000. Compute common denominator 0.060. Least common multiple of 0.015, 0.020, 0.030. Open fraction 4 times open parenthesis 5 minus lambda close parenthesis plus 3 times open parenthesis 7 minus lambda close parenthesis plus 2 times open parenthesis 9 minus lambda close parenthesis over 0.060 equals 300,000. Numerator 4 times 5 plus 3 times 7 plus 2 times 9 equals 59. Coefficient of lambda, 4 plus 3 plus 2 equals 9. So open fraction 59 minus 9 lambda over 0.060 equals 300,000. Multiply both sides. 59 minus 9 lambda equals 18,000. Negative 9 lambda equals 17,941. Lambda equals negative 1,993.44. 6. Calculate optimal spends. Xa equals open fraction 5 minus open parenthesis negative 1,993.44 close parenthesis over 0.015 close fraction equals 1,998.44 divided by 0.015 equals 133,229. Xc equals open fraction 7 minus open parenthesis negative 1,993.44 close parenthesis over 0.020 close fraction equals 2,000.044 divided by 0.020 equals 100,022. Xv equals open fraction 9 minus open parenthesis negative 1,993.44 close parenthesis over 0.030 close fraction equals 2000.0244 divided by 0.030 equals 66,748. The three numbers sum to roughly 300,000 minor rounding. 7. Interpretation: allocate about $133,000 to awareness, $100,000 to consideration, and $67,000 to conversion. This distribution equalizes the marginal ROI across stages, approximately 5.0 per $1 spent after adjustment, yielding the highest total expected revenue of R equals 5 times 133,229 minus 0.00, 7 5 times 133,229 squared, plus 7 times 100,022 minus 0.0, 10 times 100,022 squared, plus 9 times 66,748 minus 0.0, 15 times 66,748 squared. Approximately 2.1 millions. Takeaway lesson: by modeling diminishing returns with a simple quadratic ROI curve and using Lagrange optimization, you can turn a vague budget decision into a math-backed allocation that maximizes funnel yield.